Let me give you a very quick rundown of the volume reading file, notebook, sorry. And so you saw that we have many files, each with a single slice. And well, you need to be able to order them. And you do that using the slice location. By the way, you can scroll through the headers to see that you get all the acquisition information if you want. Now, what did I do to order them? I just sorted them according to slice location. I was asked if there was a preferred direction, and actually there isn't. But if you go back to the presentation regarding CT, there is a link in there that talks about the coordinates, and that's something that we will not work with, but that's the major issue. Your image are acquired in this way, and you can get a pixel by pixel matching between some internal coordinates of the scanner, X, Y, and Z, which is where you get with a pixel. But what you actually are interested in is in this system of reference, which is there are some standard medical definition, which is a superior, inferior direction, anterior, posterior, and left, right. While what you have is a matrix with I, J, and K dimensions. And by using what's saved in the headers, like here you get a Y and J for every file you read. By reading this slice location, you get a position in millimeter between every slice, and by using the pixel size and some other flags in the headers like LPS, which means left from right to left, from anterior to posterior, from inferior to superior, or the opposite, you can actually assign coordinates to pixels, which when you see an abdomen, maybe it's not an issue. You know if the heart is on the left or on the right, and you should be able to pick up a left arm from the right arm, even if people with the heart on the right side do exist. And but like if you're looking at the brain, there's no way to recognize the right from the left hemisphere. So if they don't tell you how the patient was rotated when inserted into the machine, you don't get it. So that's just a side note. Okay. So here we don't care that much. You can order increasing or decreasing. That's just switches if you get feet first or head first. By the way, probably I didn't write it explicitly in the instructions, but when you read the images, what you should do is that you should apply from the DICOM headers the rescale slope and the rescale intercept. In this case, they are not very interesting. It's 1 and minus 1024. And so again, what happens if you just display the central slice? You're just taking the central slice, you get something like that. I'm displaying that in the 3 directions. And on top of compressing all the intensity range, by the way, if you look at it, these 2 are also distorted. You see that they don't look too well. And the thing is that the pixels in the XY plane have one physical dimension, while the slices are much thicker. So what you should do is to, you can set in PyPlot the aspect ratio, and you can do that by, you can get the correct ratio by reading the headers. That's the way that the PyPlot wants it, because it puts the first dimension on the y-axis, if I'm not mistaken, and vice versa. And so like here you can do slice thickness 3.75, pixel spacing 1.36. You compute the ratios there, and if you plot them, they make more sense. Last thing is that I told you, if you apply the dicom scaling, you get you get the numbers in Hounsfield units, and then you can display them using vmin and vmax like we've previously seen. But here we have a scale, a unit of measure. So instead of guessing what looks good, we can use some standardized window. And indeed, you see here that this is what you see when you apply a tissue window. You see very well the difference from fat to muscle to bones. Even some calcifications here, the interior of the vertebrae. If you use a lung window, this is pretty much hidden, but you see everything that's inside the lungs. And if you use a bone window, you can see not too well because this is not a bone dedicated acquisition, but you can see relatively well the bone structure within the rib. So that's just to show what happens. Here, by the way, I put an histogram of the intensity values. Okay, so